Understanding the sun's magnetic field is crucial for comprehending solar phenomena such as sunspots, solar flares, and coronal mass ejections, which have profound effects on space weather impacting Earth. Space missions dedicated to studying the sun play an essential role in unraveling the complexities of its magnetic field and providing insights that are unattainable from Earth-based observations alone. The sun's magnetic field is generated by the movement of electrically conducting fluids within the sun, a process known as the solar dynamo. This magnetic field extends far beyond the sun itself, influencing the entire solar system. The variability of this magnetic field is responsible for the solar cycle, approximately an 11-year cycle, during which the frequency and intensity of solar activity, such as solar flares and sunspots, increase and decrease. One of the pivotal missions in the study of the sun's magnetic field is NASA's Solar Dynamics Observatory, SDO, launched in 2010. SDO's suite of instruments allows scientists to observe the solar atmosphere in multiple wavelengths, helping to visualize the magnetic field lines and their interactions. This data has been instrumental in understanding how changes in the magnetic field can give rise to solar flares and coronal mass ejections, phenomena that can send streams of charged particles hurtling towards Earth, impacting satellites, communications, and power grids. Another significant contribution comes from the Parker Solar Probe, launched by NASA in 2018. Designed to get closer to the Sun than any previous spacecraft, Parker Solar Probe's key mission is to trace the flow of energy that heats the corona and accelerates the solar wind, a stream of charged particles emitted by the Sun in all directions. By flying through the Sun's corona, the spacecraft collects data directly from the source of solar wind, offering unprecedented insights into the mechanisms that drive the solar wind and how the magnetic field influences these processes. The Advanced Composition Explorer, ACE, positioned at the L1 Lagrange point between Earth and the Sun, plays a critical role in providing real-time solar wind data crucial for space weather forecasting. ACE measures the composition of solar wind particles and the solar magnetic field lines carried by the wind, enhancing our understanding of the connectivity between the Sun's magnetic field changes and geomagnetic storms on Earth. In addition to these, the Solar and Heliospheric Observatory, SOHO, a project of international collaboration between ESA and NASA, has been operational since 1995 and continues to send valuable data about the Sun's atmosphere. SOHO's study of solar oscillations has helped astronomers map the Sun's interior magnetic field. This mission also monitors the solar wind and provides early warnings of mass ejections heading towards Earth, which are crucial for mitigating the impact of space weather. Furthermore, the European Space Agency's Solar Orbiter, launched in 2020, is set to join this fleet by providing close-up, high-latitude observations of the Sun. Solar Orbiter carries a comprehensive set of instruments capable of taking images of the Sun's surface and measuring the environment in its vicinity. By combining in situ and remote sensing data, the mission aims to explore how the Sun creates and controls its heliosphere and how the solar magnetic field is generated and structured. These space missions collectively contribute to a holistic understanding of the Sun's magnetic field. By studying the solar magnetic field from different vantage points and in different layers of the Sun's atmosphere, scientists can piece together a more complete picture of solar magnetic dynamics. This research is crucial not only for understanding the fundamental physics of our nearest star but also for improving our ability to forecast space weather events that can affect life and technology on Earth. In conclusion, space missions that study the Sun's magnetic field are crucial for advancing our understanding of the Sun, solar phenomena, and their impacts on space weather. The data and insights gathered from these missions help protect our satellites and communications networks and enhance our knowledge of the universe. As these missions continue to provide data and as future missions are developed, our understanding of the Sun and our capacity to live and operate safely in space will be significantly enhanced.